So to draw a slope field, what you can do to make a sketch is to draw your x and y coordinate system and then start picking some points. Like let's start right here at 0, comma 0. Oops. Okay. So I'm plugging in 0 in for x and 0 in for y into this differential equation. There's actually no place to plug in a number for y. So we're just going to plug in 0 in for x, and what that's telling us is that the slope at that point I picked is a 0. So we're just going to draw a horizontal line for a slope of 0. So let's go over to 1 comma 0. If I plug in 1 in for x into my equation and 0 in for y, well, there's no place to plug in y. That's okay though. If I plug in 1 in for x, I've got a slope of 1, right? So if you're to draw a slope of 1, it should go up 1 to the right 1, up 1 to the right 1. But we're just going to draw a tiny little slope here. That way we can see how all the slopes are interacting over the entire graph. So if I wanted to know what the slope is at 2 comma 0, and that's why putting these hash marks can be troublesome, because you might be thinking like that little vertical line is supposed to be your slope field. So I'm going to stop making those vertical lines now. If I plug in 2 for x, 0 in for y, I think you can probably see what's going to happen without me drawing this out again, right? This is a slope of 2, so it should be a line that's a little steeper than the last one. And then once we get to 3 on the x-axis, we should be even steeper. So we're getting closer and closer to vertical lines the further we go on. Okay, so we took care of a bunch on the x-axis. Let's go the other direction. Let's do it at -1. If I plug in -1 in for x and 0 in for y into my equation, I get a slope of -1. So that looks like this. And if I plug in -2, I've got a slope that's a little steeper. Oh, sorry, that's not a negative slope. That was stupid of me. That should look like this. That's a negative slope. Down 1 to the right 1, down 1 to the right 1. And the next one's a little steeper. The next one's a little steeper because now we got a slope of -4, -5. It's a rough sketch. And then let's go up on the y-axis. How about at the point at the point 0, comma 1? If you plug in 0 in for x and 1 in for y, well, this equation doesn't have anything to plug in for y. So this slope is going to be, the tough part is I had to draw that 1. This slope is going to be a horizontal line here, right here. At 0, comma 1, we had a slope of 0. And at 0, comma 2, we also have a slope of 0 because you're plugging in 0 in for x, right? Let's try another point. Let's go right here at 1, comma 1. If I plug in 1 in for x, 1 in for y, I get a slope of 1. The slope is 1, so it's actually going to be the same slope as what's below. And if I go to 1, comma 2, that means right around here in my x and y coordinate system. So 1 in for x, 2 in for y. There's no place to plug in 2 in for y. That's okay. We just plug in 1. We get the same slope. So these are all going to be the same direction. They're all parallel, these slopes. Okay, and then you can see that happening over here. 2, comma 1. That has a slope of 2. So 2, comma 1, this is what the slope field should roughly look like. And at 3, comma 1, same deal. They should all be parallel to this one that we drew down here because you're just plugging in 3 for the x-axis. And so now you can start seeing the slope field form. These are all going to be slopes of 0. And then over here, these are all going to be slopes of -1. And then slopes of -2. This one should look something like this. And so on. Okay, so that's how you draw a slope field. Let me do one more that involves the letter y, though. So different differential equation this time. We're going to do the same process, though. Pick some points, find out what the slopes are, and draw many little slopes in there to get an idea for the slope field. And you might be wondering why we're doing this. Slope fields can help us find solutions to differential equations. Okay, if you can draw, eventually, I think that's something we'll do later on in the textbook, but you can draw lines to help you spot what kind of function might be a solution to the differential equation, so it can point you in the right direction. So dy dx equals -x over, so here I'll do the classic 0, comma 0, but this one's going to be undefined, right? So that's kind of a weird one because we're dividing by 0. Let's hold off on that. Maybe we'll have some clues on the next one. If we plug in 1 in for x and 0 in for y, because that point I just circled is 1, comma 0, this one is undefined. Looks like this. Okay, it's a vertical slope because when you divide by 0, that's a vertical slope, right? Like those vertical asymptotes we did in pre-calc. So let's do the point 2 comma 0. Same deal. You got -2 over 0, so that's also going to be a vertical line. And any point you plug on the x-axis, you're going to be dividing by 0, so these are all going to be vertical. So let's try this point right here, 1 comma 1. If I plug in 1 in for x and 1 in for y, then I've got -1 divided by 1. So I get -1 for my slope. That's what dy dx equals. So my slope should be -1 at this location, at -1 comma 1. If I plug in 1 comma 2, then I'm plugging in 1 in for x and 2 in for y. That's a -1/2. So that's a slope that's closer to 0, so it shouldn't be as steep as the last one. And if I do 1 comma 3, I plug in 1 in for x, 3 in for y, so it's still a negative slope, but it's closer to a horizontal slope because it's even closer to 0 than the last one. So you can see the pattern. They get really close to horizontal lines as we go up. Let's try below. Maybe it does something different, so let's get some points all over the place. Plug in 1 in for x, -1 in for y, so we've got -1 divided by -1 makes a +1 for a slope. If I plug in 1 comma -2, I'm plugging in -1 in the top and then -2 in the bottom, so that's 1/2. So that is another, wait, on the last one, sorry, that's a positive slope, but it's a little closer to 0, so I'll make it level off a little compared to the last one, and then as we go down they should level off more and more. And then same thing over here. If we plug in -1 for the x and 1 for the y, let's see what the slope is at this location. So that's a -1 makes a +1. 1 divided by 1 makes 1 for a slope. And then up here, if we plug in -1 in for x, 2 in for y. So -1 makes +1, 1 over 2 makes 1/2. So that's a slope a little closer to 0. So this is going to do the same type of thing. It's going to start leveling off. So I hope this gives you the idea. It's kind of cumbersome, but if you're doing one of those matching questions, draw them out yourself. Okay, that way you really understand how a slope field is made. That way, if you're asked a different question about slope fields, you'll be able to do it. Okay. I hate seeing it so incomplete. So I'll just do a few more. This is -1 on the x, -1 on the y. I'm going to do next. So -1 makes +1, divided by another -1 makes -1 for a slope. And then they're going to start leveling off again because now it's going to be 1/2, 1/3, 1/4, 1/5. They start getting closer and closer to 0. And I can't resist. Let's do a few more. -2 in for x, 1 in for y. So -2 makes +2. 2 divided by 1 makes 2. So this one should have a little bit of a steeper slope than its partner over here, because this is a slope of +1, so this is a slope of 2. But as you go up, this would be a slope of 1, and then a slope of 1. What would be the next one? 2/3. It starts leveling off, though. It gets closer and closer to 0. And then down here, if you plug in -2 for the x, -1 for the y, so -2 makes +2. 2 divided by -1 makes -2, so it looks like this, but then it starts leveling off. Okay, we got an idea for what the slope field is going to look like. We can keep going like that.